and welcome, and in this video we're going to be talking about solving quadratic equations by taking square roots. I sometimes refer to it as a square root method, and we can only use this in very specific cases. But when we can use it, man, is it so much easier. So an instance would be something like this: 25x squared minus 7 is equal to 0. Now, the reason we can use the square root method here is because there is no linear term. There's no 3x or 4x or negative 5x term. It's just an x squared, a quadratic term, and negative 7, which is the constant term. So we're missing the linear term. So when we're missing the linear term, we can solve by simply taking square roots. And to do that, we first need to isolate the quadratic term. And the quadratic term is x squared. We need to isolate x squared. So the first thing that we would do is we would add 7 to each side, and that would leave us with 25x squared is equal to 7. From here, I still don't have x squared isolated, so I'm going to need to divide each side by 25. So I'm dividing each side by 25, and that gives us x squared is equal to 7 over 25. And now that we have x squared isolated, we can now take the square root of each side. The thing you need to remember is that when you take the square root of each side, you need to have plus or minus. There are going to be two solutions, and the plus or minus are going to get you those two solutions. Also, we cannot have a fraction inside of a square root, or any radical for that matter, because that's the exact same as having a square root or radical in your denominator. So when I take the square root of each side, I'm going to make it x equals plus or minus, right? Square root of 7 over square root of 25. This is the same as the square root of 7 over 25, all right? So I can split up the square root. Now I need to simplify. If I can simplify the numerator, make sure you do so. We can't. If you can simplify the denominator, make sure that you do so. And we can, because the square root of 25 is 5. So we get x is equal to plus or minus the square root of 7 over 5. And that would end up being our final answer, okay? Now, if you did have a square root left in your denominator, you would have to rationalize this problem. And we'll be talking about that in the next problem. So let's talk about a new problem. So we have 3x squared plus 8 is equal to 0. Once again, we are missing the linear term, so we can solve by using square roots. So I'm going to isolate the x squared. I'm isolating the quadratic term. So I'm isolating x squared, so I need to subtract 8 from each side. And when I do that, I get 3x squared is equal to negative 8. Now I still don't have x squared isolated, so I need to divide each side by 3, which is going to get me x squared is equal to negative 8 thirds, or negative 8 over 3. And this is where we need to take the square root of each side. And remember, we cannot have a fraction inside of a square root, so I'm going to split that up into being the square root of negative 8 over the square root of 3. And whenever we take the square root of each side, we need to have plus or minus. So this is going to become x is equal to plus or minus the square root of negative 8 over the square root of 3. And now we have to simplify if we can. Now, one thing, I have a negative inside the square root. Whenever you have a negative inside the square root, what you're dealing with is imaginary numbers. So I'm going to need to pull out an I from that square root, and that now becomes plus or minus I root 8. So whenever you take out an I, what's underneath the square root now is positive, because I is the square root of negative 1. From there, I need to see if I can simplify, and we can simplify the numerator. The numerator, the square root of 8, can be simplified to 2 root 2. So this now becomes 2i root 2, because that I is out in front. Okay, so we now have x is equal to plus or minus 2i root 2 over the square root of 3. And now I can't simplify the square root of 3, and I can't have a square root in our denominator. So we're going to have to rationalize this. So I'm going to have to multiply by the square root of 3 over the square root of 3. Remember, that's just multiplying by 1, so we're not actually changing the problem at all. We're just rationalizing it. And that's now going to become x is equal to plus or minus 2i root 6 all over 3. And that is another example. So as you can see, it's actually a lot quicker to solve using the square root method as opposed to try to factor or use a quadratic formula or complete the square, which we'll be talking about in a little bit. Okay, let's take a look at one last problem, and these types of problems are a little bit different, but using the square root method is really nice here. Okay, so let's take a look at this problem. Now, if you are not going to use the square root method, you would have to actually multiply that out, combine like terms, and then try to figure out how to solve it. However, there's a much easier way. I can isolate x plus 5 quantity squared and once again take the square root of each side and cancel out that square entirely. So we can still use the square root method. So what I can do is I can add 49 to each side. That's going to get me 4 times x plus 5 quantity squared is equal to 49. Now I still don't have the squared term isolated, which is x plus 5 in this case, so I need to divide each side by 4. When I divide each side by 4, I'm left with x plus 5 quantity squared is equal to 49 over 4. So then I can take the square root of each side. So now when I take the square root of each side, the square and the square root are going to cancel out, leaving me x plus 5 on the left-hand side is equal to, remember, plus or minus the square root of 49 over the square root of 4. And now we simplify if we can, and we can. The square root of 49 is 7, and the square root of 4 is 2. And now all I have to do is subtract 5 from each side, and I'm going to get x is equal to negative 5 plus or minus 7 halves. Now you're not actually done because you can actually combine these two numbers. We can do negative 5 minus 7 halves, and we could do negative 5 plus 7 halves. And that is going to end up giving us our two answers of negative 17 halves and negative 3 halves. And that would end up being our final answer. So that is solving by taking square roots. I hope this video was helpful. If there's any questions, please feel free to let me know. And I look forward to seeing you guys in the next video.